Hey everybody, this is George Jefferson, and I'm happy to be moving on up. Let's first do board problem 8.6, and this lesson will be an Algebra 2 lesson on solving rational equations. Okay, let's go ahead and begin with this. I'm going to go ahead on number 1 and cross multiply. Whenever you have a fraction equaling a fraction, you can cross multiply. So 6x equals 4 times 15, so which is 60, so x equals 10. Okay, number 2, that's easy enough. Everybody knows how to do that. Distribute through, and then you're going to subtract 15x and then add 4 to both sides, and I get x equals negative 6. Alrighty, and okay, this next one is going to be factoring first, you guys. Now, there is a guessing and checking method, you guys, and frankly, I suck at guessing and checking, so I don't know. I just lose patience with it. I can do it, but I just lose patience with it. This way it goes kind of fast once you get the hang of it. And what I do is I multiply these outer two numbers. Now I can't factor this right away because of that 2 right there, and I can't GCF out a 2 out of all the things because of the 5 right there. So if it does factor, I multiply these two numbers in my head, but I showed you this right here. So 2 times negative 12 is negative 24. And then I think of all the factors of negative 24 that add together to be 5. Now I'm at school, you guys, so we may hear maybe an announcement here and there or just some noise outside. So anyway, so negative 24 also equals 8 times negative 3. And if I added 8 plus negative 3, that would be that 5x right there. So what I'm going to do is replace this polynomial, replacing the 5x with 8x minus 3x in the middle right there. And then I can do a factor by grouping, you guys. And factor by grouping just means I just think of these two guys right here. And what's a GCF? I can pull out a 2x squared and 8x. I can pull a 2x out, and I'm left with x plus 4. Okay, then I GCF these second two guys. I always pull this sign out, always. So if it's a minus and I pull it out, it's going to change this sign right here to a plus right here. Okay, hopefully you guys can see that I can pull a 3 out of both of those, and I'm going to pull a minus 3 out of that, so that's going to change that to a plus 4 in there. And then can you see now, both of these guys have a red x plus 4, so I'm going to pull out the red x plus 4, and I'm left with the blue stuff, 2x minus 3. Okay, so there it is factored, and that works on all those ones if that's not 1 right there. And I love doing this method because I can get it really, systematic anyways on that. All right, now set the factors equal to 0. And then so x plus 4 equals 0, 2x minus 3 equals 0, and you get x equals negative 4 or 3 halves. All right. Okay, so here we go, solving rational equations, and this is section 8.6 in my book, so it might not be in your book, but anyways, here we go. And then let's just solve, okay? Okay, this one's just like that board problem. I'm going to go ahead and cross multiply on this. Whenever I have a fraction on the left equals a fraction on the right, you can do cross multiplication, okay? So I cross multiplied, did this times this is here, and then this side equals this times this. That's what's over here. Okay, go ahead and distribute the 7 through and the 11 through, and then go ahead and solve for x, and you end up getting x equals 16. Okay, easy enough. That's kind of from Algebra 1 also, you guys, so hopefully you can do that. Okay, here's a little bit of new stuff, you guys. Looks kind of freaky, and a lot of kids just stop on these because they see the fractions. And don't let them freak you out, you guys. Whenever you have an equal sign, you can make fractions disappear by multiplying by a common denominator. Can you see this has an x, this has a 5, this has an x? My common denominator is 5x. So multiply everything by the common denominator, 5x. And what that does is it makes those denominators disappear. See, the x's cancel. I'm left with 5 times 15 is 75. Here the 5's cancel. I'm left with x times 4, which is 4x. And here the x's cancel. 7 times 5 is 35. All right, so then solve and you get x equals negative 10. Okay, piece of cake, you guys. I mean, look how easy it made it from here. It went down to here, and it's way easy by getting rid of the denominators. All right, let's try this one. Same thing, you guys. Remember, this is like 1 over 1. So I'm going to multiply this. This denominator has x plus 1. This denominator has x. So my LCD is x times x plus 1. So I'm sorry, it should be a plus 7. I'm sorry, I forgot to change that. This should be a plus 7 right there. Let me change that right now. My bad, as you students say. Let me change that. I thought I changed them all. That's a plus 7. Okay. All right, so plus 7. So I multiplied everything by the common denominator, x, and then x plus 7. I had x plus 1 earlier, and I wasn't getting the correct answer, and so I had to change it to x plus 7. So I didn't change that slide. All right. Anyway, so now look, you guys, the x plus 7 cancel. I'm left with 12 times x. Over here, nothing cancels, so go ahead and distribute x times x is x squared. X times 7 is 7x right there. And over here, the x's cancel and distribute. Be careful, it's a negative. There's a minus sign. Negative 12 times x and negative 12 times 7 gets me that right there. Okay, let's clean it up a little bit. Okay, and I get that. I flipped it around. I just flipped it around and combined like terms. 7x plus negative 12x is negative 5x equals this 12x. And now quadratics always have to make them equal to 0, so I'm going to subtract 12x over here from the negative 5x. Negative 5x minus 12x is negative 17x. Quadratics always have to equal 0, and it's a quadratic because it's squared. Now I'm going to factor this. Factors of 84. This one's kind of hard to see, you guys. There's all kinds. Most of you guys are probably thinking 12 times 7, but 21 times 4 also works, and 21 and 4 are the pair that's going to make it negative 17. So one's going to be negative 21, and one's going to be a positive 4, x minus 21, x plus 4. Okay, and then when you set them equal to 0, you get x equals 21 or x equals 4. Okay, and just kind of glance back up, you guys. Remember, you can't have 0 in the denominator. So if I got like x equals negative 7, I'd cancel that one out because it couldn't be negative 7. And it couldn't be 0 because this one would make it 0 right here. But none of those give me 0 in the denominator, so that's the answer right there. I should have put a box around it. I didn't. All right, let's try this one. Okay, going to multiply everything by x minus 2, including the 7, you guys, x minus 2. All right, so now the x minus 2's cancel. Look, I'm left with 5x here, 7x minus 14. Here, those cancel, 10. Now this is a simple pre-algebra question right here, you guys. You get x equals 2. All right, now check it out. Does it give me 0 in the denominator when I get x equals 2? Yes, and you can't have 0 in the denominator. So whenever that happens, it doesn't work. You say no solution, and that x is called an extraneous solution, you guys. I forgot to close those parentheses. All right, so you don't need to know it's an extraneous solution. You just know that it doesn't work. And if it is one of the answers, it does work. Extraneous means a false solution, you guys. They're just getting fancy with that fancy name, you guys. Okay, but it's no solution because we got x equal 2, and 2 gives me 0 in one of those denominators. Okay, let's try this guy here. Okay, let's first, now you can cross multiply on this, you guys, because you have a fraction equals a fraction, but boy, you get some messy looking quadratics. I wouldn't touch that one at all. And I have, you guys. So first, factor the denominators first, and then we'll multiply both sides by the LCD. It cleans it up right away, you guys. Okay, this one is a perfect square trinomial because that's 3 squared, and so it gives me a binomial squared. This sign right here always goes in the middle. So x minus 3 times x minus 3 equals this. Over here I can GCF an x out. Okay, remember my lowest common multiple, or my lowest common denominator, is most of every factor that I see. This one has an x, this one has an x minus 3, but this one has 2x minus 3, so I want to have them both x minus 3's. So that's my LCD. So now I'm going to multiply everything by x minus 3 squared. Okay, and what that does is it gets rid of this whole denominator. Can you see this guy canceling out with this? I'm left with 9x. Over here, all of this cancels out all of the x and one of the x minus 2's. So watch, you're going to get, and I distributed the 3x through. 3x times x is 3x squared. 3x times negative 3 is negative 9x. Okay, got to make it equal to 0, so I'm going to subtract 9x. Careful, don't make the Algebra 1 error. Negative 9x minus 9x is minus 18x, you guys. Okay, so now it's equal to 0. Now we're going to factor it. So 3x times x minus 6, I can GCF that out. So I get x equals 0 or x equals 6. And does 6 or 0 give me, and look at the factor denominators right here. Does 6 or 0 make any of these a 0 right here? Right here, if x equals 0, I get 0 times 0 minus 3, which is 0. 0 can't work. It makes 0 in the denominator of one of the fractions. So you got to cross that out. And x equals 6. All right, now this is out of my textbook. It's page 593, numbers 5 through 23. But if you're in a different textbook, or like me, I'm going to be changing textbooks in another year and a half or so. This would be the homework right here. So these 5 through 23, the odds. And then so pause it and write them down. And then on the next slide is all the answers. Okay, and you can pause that and write that down.